All right, welcome back. So the next thing we're going to be taking a look at here is the heart. So when we start looking at the cardiovascular system, we are now looking at the main pump for this. So when we really get down to this, what does the heart need to be able to do for us? Well, we know we have a two-sided circuit, so we need a double-sided pump where the blood isn't mixing because one is oxygenated, one is deoxygenated, at least on the way to the lungs versus the way back. So we can't have this blood mixing on there. What else do we need? Well, we need to ensure one-way flow through that because each circuit is a one-way circuit where it's looping back to the heart. So we need to make sure that blood is only going one way through the heart and not being able to be forced back in the wrong direction. We need this to continue working every day, every hour, every minute. So the heart can't stop. If the heart stops just for even a few seconds, you can lose consciousness. If it stops for longer than that, you can lose your life. So in reality, we need this to keep working all the time. And then also it needs to be able to regulate its output to the activity level. So a lot of times if you're sitting, you don't need your heart doing a lot, but if you're out there trying to run the fastest mile you've ever ran, you need your heart to be able to respond to that increased activity level by supplying more flow, more output in order to deal with that. So what we're going to be looking at here is a little bit of how the heart is put together, and then later on in this we'll be looking at how the heart does its job and how we regulate control of the heart. So first off, how is the heart put together? Again, it is supplying two different circuits, the systemic versus the pulmonary circuit, and we're going to see the heart is kind of subdivided into upper and lower chambers, but also side by side. Blood on the right side of the heart is not mixing with blood on the left side of the heart, and this is kind of sending blood out to a particular circuit and bringing blood back from the other circuit. Again, almost if you think like a figure eight in the center, stuff going out one side, coming back to that center, going out the other side, coming back to that center. Again, something definitely to keep in mind on this. Again, two main circuits. It's really two separate pumps that function as a single unit together. But in those two circuits, where you're pumping in that pulmonary circulation, taking deoxygenated blood from the right side of the heart, sending it to the lungs where it's going to pick up oxygen, release carbon dioxide, and then it's going to return to the left side of the heart, which is then going to take it out to the systemic circulation through the left side of the heart, take it to all these different areas of the systemic, bring it back to the upper chambers on the right side of the heart. So blood, if you were to be following it through here, it's just going to be this basic repeat pattern over and over again. Right side of the heart to the lungs, back to the left side of the heart to the tissues, back to the right side of the heart to the lungs, back to the left side of the heart to the tissues, and we're going to do that over and over and over again. Again, what we need happen on this is the balance of blood coming into each side needs to be pretty equal, what's going in and out of each side, because if it is unequal at any level, sooner or later, we would know if you're always sending a little bit more to one side versus the other, you're going to get a buildup of fluid on that particular circuit and not on the other, and that can lead to edema and like all this excess tissue fluid if this balance isn't correct. So here's a picture of a heart. The size of the heart is, again, not as big as you've probably seen on TV. About 7 centimeters long, so 2.5 centimeters per inch. So we're looking at 4 to 5 centimeters long, 3 to 4 centimeters wide. It is located in between the two lungs, underneath the kind of upper part of the chest here, beneath the trachea. Gonna be down the middle here. You have this mediastinum between the pleural cavities that's in there. We're going to see it's slightly angled to the left side. The apex of the heart goes a little bit over onto the left side and takes a little bit of space of that left rib. Again, everything reminding everybody here, it is the subject's left and right. So if you're looking at the screen here, the left and rights might not match up as to what we're pointing out. But the apex of the heart, this would be the left lung. It is going to make a little notch on that left side. If you're saying put your hand on your heart, it is not here. In reality, it's more of kind of something like that. The heart is surrounded by a number of connective tissue layers. So we've talked about these serous membranes before. We know the pericardium is this fiber sac that surrounds the heart. You have the lining of that pericardial, that fibrous pericardium is the parietal pericardium. We then have space filled with pericardial fluid. And then the outer layer of the heart is the pericardium, which is also known as the epicardium of the heart. This is covering that heart surface. So that's really the outer layers that we're looking at. And at any particular time, you have about somewhere between 5 and 30 mils of pericardial fluid. This is all about reducing that friction. If you were to take your fingers and kind of go like this over and over again, let's say just do 60 to 80 beats a minute, you're going to feel the back of your hand start getting warm. I'm not going to spit on the back of my hand, but if you were to go and spit on there, there's going to be less friction, generates less heat. That is really what's happening with pericardial fluid here. We have a heart that's continuously beating. We don't want it rubbing on the other tissues and causing damage or generating heat. Because of that, we have this pericardial fluid that is going to act basically as a lubricant around this heart to try to keep it from generating heat and friction. And this is showing you the wall of the heart now. We're going to see we have 3 main layers to the heart wall. You're going to have the main body of the heart wall is that myocardium. That is cardiac muscle. You have the serous membrane on the outside, the visceral pericardium. We are also going to have what is called endocardium, which is simple squamous epithelium on the inside. And that is endocardium. And this basically is just giving you a nice little summary of the different layers, what they're made of, what they're functioning to do. And when we look at the heart here, and again, the one thing I do want to point out is the sizes of the particular chambers are not representative a lot of times in these images. It makes the atria look a lot of times much larger and the right side look much larger than the left side. In reality, there's a lot more muscle mass on the left side of the heart, and the atria, the space in there is really not as large relative to the ventricle as we're seeing on these ones. But you have 2 upper chambers that are called atria. Single on that one would be atrium. You have 2 lower chambers that are ventricles. Blood is going to be received into these upper chambers, pass through a valve into the lower chambers, then get pumped from those lower chambers, ventricles, out through another valve to either the systemic or the pulmonary circuits. And if you're kind of looking at here, you can see the external anatomy here. You have the main veins, the superior and inferior vena cava, taking blood to the right side of the heart, the right atrium. Really, a lot of the right side of the heart is more on the anterior side. You can see there's pulmonary veins bringing blood back from the lungs. It is going to get into this left atrium and down to the left ventricle, and then is pumped out through the aorta to the different branches of the systemic circuit, where the right side is pumping out through this pulmonary trunk to the left and right pulmonary arteries to take blood to the lungs. So this is a very muscular organ. Like I said, 2 small atria, 2 much larger ventricles. We have a lot of grooves in between some of these areas that are housing blood vessels that supply the heart. A lot of times we talk about that as being the coronary vessels of the heart. And there's a big groove in the back side of the heart that extends between the atria and the ventricles called the coronary sulcus, that is all the way around the heart where it's separating those parts, the upper and lower chambers. We're going to see this actually as we get in a little bit further is going to have some fibrous tissue here where the muscle from the atria does not come into contact with the muscle from the ventricles. So this, you can kind of see this. This is kind of showing you that sulcus going around the left, all the way around the heart. And you can see it on the back side right here, separating the atria from the ventricles down on the bottom here. There is this groove a lot of times where you have the main coronary vessels traveling down to the apex of the heart. We're going to have these interventricular sulcuses, both on the anterior and the posterior side. These are housing blood vessels of the heart, these main coronary arteries that are supplying the ventricles of the heart. If we start going and looking at the front side of the heart, the most prominent things are going to be the right ventricle and the right atrium. There is a little flap-like extensions of these atria called auricles. And you would also see the pulmonary trunk and the aorta coming from the top of the heart. So you can see this right here. This would be the right atrium. The right ventricle is mainly right here. You can see the pulmonary trunk, the superior and inferior vena cava. If we were looking at the back side of the heart, what is more obvious on here is going to be the left ventricle and the left atrium. Right here, you can see these pulmonary veins bringing blood back from the lungs. Like I said, on the back side It's just that the heart is kind of twisted a little bit. The left and right is kind of a little bit more anterior versus posterior for the left. Left atrium and left ventricle will be much more prominent. You see the pulmonary veins, like I said, coming back in, and you can see those other blood vessels that are supplying the right side of the heart. And you can see this again right here, left atrium, left ventricle. What we are going to see if we look inside these on the wall there are certain parts of these that are the atrium that are going to be a smooth surface, and then you have this area with these muscular ridges with spaces in between them. These are called pectinate muscle. You'll see these on both left and right atrium. In the right atrium as well, you have this depression in there called the fossa ovalis. During fetal development, which we will talk about a little bit, there is a connection between the left and right atria. This is because during fetal development, blood is not going to the lungs, so we have some bypasses for the lungs. There is actually a hole in your heart that's present there right up until birth where you can shunt blood from the left to the right, from the right to the left side of the heart. So we're not having to send blood to a circuit that we're really not needing to. This is left as a depression. The remainder of this foraminal valley becomes the fossa ovalis. There's also a small opening from that coronary circulation called the coronary sinus that is coming in just beneath that fossa ovalis, which is draining blood from the coronary circulation from that main vein on the back side of the heart. If we go down the right ventricle, you have these regular ridges that are down there that are called trabeculae carneae. To me, it sounds like Mexican dinner dish, kind of like carne asada, but these are these muscular ridges down there. The other thing you're going to see like these kind of cone-shaped muscles that look something like this that have these tendinous materials connected from those to the valves that are separating the atria and the ventricles. These are called papillary muscles. These papillary muscles are, like I said, attached to these AV valves by the chordae tendineae. These are collagen fibers, and what these really do is really putting a lot of assistance to those valves, so you, when your ventricle contracts, you don't blow that valve open and send blood back to the atria. So by having these chordae tendineae there, it's kind of like a door stop or a chain on a door that keeps it from swinging the wrong direction. Again, left atrium, very similar to the right one, has those pectinate muscles. Left ventricle is going to have trabeculae carneae, has some very major papillary muscles, and then you can see the aorta's exit kind of underneath one of those valve flaps or cusps on that ventricle. And again, this is the point I was trying to make, that there's a lot more pressure necessary to pump everything to the systemic circuit. If you think about the lungs, they're right next to the heart. There's not a lot of blood vessels to push that blood through. If you're looking at the systemic circuit, a lot more blood vessels when you're talking about going to your legs, your head, everything else like that. Much higher pressure system. Because of that, there's a lot more muscle in the walls of the left ventricle in order to push that out at a higher pressure. So you can actually see that in this image right here. There is septums in both the atria and the ventricles that separate the left and right sides of the heart. Like I said, sometimes that fossa ovalis doesn't close, or foraminal valley that becomes a fossa ovalis, sometimes it doesn't close. That can be a problem. Then again, there is also a septum of muscle separating the ventricle. So again, we do not have mixing of that blood in the chambers of our heart. And this, again, you can see everything that's here. We were talking about this. If we're looking at the valves, you can see this is the two main, what we call atrioventricular valves. You can see one of the two, what we call semilunar valves. The other one is actually underneath this tissue. Again, we can't see both valves in the same thing here, because if you were looking at the aortic valve underneath this pulmonary valve, it's actually underneath this tissue right here. So it's not really possible to do a drawing that shows them both, because one is honestly directly on top of the other one. So what we'll pick up with next time is we'll start looking at some of the actual valves in here, and then start getting into some of the components of how blood travels through the heart. So I will see you next time.